This is Vogtle Timeline with your host, Joe Washington.
Looking in every direction, it's clear that progress is steady and on track here at the construction site of Georgia Power's 2 nuclear energy facilities. Welcome back to Plant Vogtle in Burke County, Georgia, where approximately 2,300 employees are on the job now and nearly 10 million work hours have been logged to date. This new generation of nuclear energy facilities is the world's most advanced. Comprised of the Westinghouse AP1000, it's designed to incorporate modern modular construction techniques. This means that construction activities that previously were done sequentially can now be done concurrently. Factory-built submodules and other materials that have been fabricated all over the world are arriving daily. Thousands of components will be assembled here to construct America's first AP1000 reactors. The first of those are parts for the CA-20 structural module. As you can see, these parts are stood up on end where they reach 68 feet in height and are then welded together. 8 seams have been completed to date. The CA-20 is the auxiliary building for Unit 3, where most of the safety systems associated with the reactor will be housed. The next module that will be assembled in the modular assembly building is called CA-01. It will house the reactor vessel, 2 steam generators, pressurizers, and associated equipment, and will eventually be placed inside the containment vessel. Once these giant modules and others are assembled, it's certainly going to require equipment with remarkable strength to move them into place. In previous timeline reports, you've probably seen this enormous heavy lift derrick crane in the background. This extraordinary machine will put the huge modules into place by performing what's called critical lifts. To prepare for these big moves, test lifts were recently conducted here. To tell us more about this, we go to Karen Stoner. She's the project manager in the nuclear division of Shaw Power Group.
A test lift is the actual lifting of concrete blocks to ensure that the capacity of the crane can lift as designed and can do so safely. In this case, the crane was tested at 100 to 110% of its largest lift, which is 1,520 tons. The HLD's first lift will be to take the nuclear reactor vessel off the rail car. The second lift, which is actually the first permanent installation, will be to place CR10 steel on the nuclear island base mat. The heaviest lift this crane will make is CA-01 module. It is 1,300 tons, which, to put that in perspective, a school bus weighs approximately 20,000 pounds, which is 10 tons. That means we are lifting approximately 130 school buses. Critical lifts that will be performed are the steam generators, the CR10 steel, the CA-20 modules, CA-01 modules, and actually the containment vessel bottom head itself. Some of the interesting facts about the crane is that the boom itself is 560 feet tall. This is actually 20 feet taller than the existing cooling towers at Vogtle's Units 1 and 2. The back mast is 280 feet tall. There are 8 miles of cable. The cable diameter is 2¼ inches. The crane itself weighs 6.5 million pounds, and the diameter of the rail that the HLD sits on is 300 feet. It takes approximately 20 minutes at full speed with no load for the crane to go full circle. This crane is actually one of 2 owned by Shaw.
Thanks, Karen. Here at the construction site, we break everything down like this. There's the nuclear island and everything that's not the nuclear island. If it's not part of the nuclear island, it's known as the balance of plant. This includes the turbine island and the cooling towers, among other areas. And there's a lot of activity on the balance of plant, as heavy equipment operators, iron workers, carpenters, and laborers are making significant headway in bringing these structures into focus. At the Unit 3 turbine building, 600 tons of rebar have been installed to date, and the concrete base slab is almost complete, with approximately 5,700 cubic yards poured so far. Building the exterior walls up to ground level is the next step, and then the backfill will continue to that height. The turbine is where energy from the high-pressure steam will be converted to mechanical energy. This energy turns the generator, which produces electricity to meet our everyday needs. The condenser's job is to convert the steam that passes through the turbine back into water. Work on the Unit 3 condenser is underway as tube bundles are set and leveled and then will be welded in place above the lower shell. Now, to remove the heat from the water discharged from the condenser, natural draft cooling towers will be used at Plant Vogtle's new units. Here's Ralph West, construction manager for the turbine island and balance of plant, to tell us more.
The natural draft cooling tower has very few moving parts. The water is pumped in, the water flows over the fill, it's dispersed down to the basin at the bottom. It cools the water on the way down, and the heat is drawn by natural draft out through the top of the tower. Unit 3 cooling tower, at this point we have the foundation work complete. The ring beam on Unit 3 is now complete. We are in the process of pouring the pile caps, and once that's done, the exterior walls will begin. We're approximately 40% complete. The reason that doesn't show so much is all the underground work is complete. We will start the walls in the next month or so. The Unit 3 cooling tower at this time has 4,700 tons of rebar installed already, and we have placed 42,000 cubic yards of concrete in this location. The Unit 4 cooling tower, all the underground work is complete. We are pouring mud mats at this time. The first two sections of the ring beam is in progress of being formed and rebar installed at this time. The new cooling towers are very similar to Unit 1, Unit 2. They are 50 feet taller than Unit 1, Unit 2. The base area is 500 feet in diameter. The height will be right at 600 feet.
Thanks, Ralph. The two cooling towers will be completed within approximately 12 months of each other. The demand for electricity here in the Southeast is growing as fast as this construction project, and Georgia Power is responding to this demand by ensuring that future generations of Georgians have the affordable energy needed to sustain a strong, vibrant economy. Our uncompromising focus remains on safety and quality. Our customers expect and deserve a reliable, safe, and clean source of energy. Vogtle Units 3 and 4 will be the first new generation nuclear plants in the United States and another step toward our country's energy independence. That's all for now. In our next report, we'll look back over 2012 at the major milestones and achievements here at the site of America's nuclear energy renaissance. We hope you'll join us then for the next Vogtle Timeline.
Follow Georgia Power on Twitter at Georgia Power and Twitter at Southern Nuclear, and also at Georgia Power and Southern Nuclear on Facebook.